Hi, welcome to the tutorial on Data Exploration Target Variable Part 3. By the end of this topic, you will be able to explain why outliers occur, explain how outliers cause problem in analysis and modeling, list different ways of treating outliers, and treat outliers by imputing. Now in the previous tutorial, we learned what outliers are and how to identify them mathematically. Now, let's understand why outliers occur in the data. The outliers could be due to genuine variability in the data or due to a recording error. For example, in our data, it is quite possible that the house whose sale price is recorded as 7.7 million was actually sold for that price because maybe it is really a large house at a prime location with lots of unique features such as posh locality, top-notch facilities like schools, hospitals, shopping malls in close vicinity, quality of construction, builder and architect reputation, car parking, security arrangements, greenery all around, and pool and club facility, etc. etc. In which case, it is an example of a variability in the data. Or it could be that the house was actually sold for 770k, but while entering the data, someone made a mistake and entered an extra zero, and we wrongly recorded the sale price as 7.7 million, in which case it is an example of recording error. Outliers can cause serious problems in statistical analysis and modeling, and it is important to identify and treat them beforehand, especially if we suspect them to be due to recording error. So now we have understood how outliers can occur. Now we will understand how outliers cause problems in analysis and modeling. Let us understand this with an example. Now, you may have heard of the joke that if Bill Gates is drinking in a bar, on an average, everyone in the bar is a millionaire. Hearing this statement, one may think that everyone in the bar must be really rich, but in reality, everyone could be earning just normally, and it's just that Bill Gates is a billionaire, and if you add his wealth to the rest of the people present in the bar and then take a simple average, the average would come out to be really high. So Bill Gates is an outlier whose presence substantially changed our understanding or perception of income of rest of the population. And if we want the true picture of average wealth of the members of the bar, we should remove Bill Gates from the dataset and then calculate the average. Hope now you have understood how outliers can cause serious problems in our analysis and hence why it is important to treat them beforehand. When outliers occur due to a recording error, it is imperative that we treat them. Even if you believe outlier is not a data error but represents a genuine data point, it is advisable to treat it since its presence can significantly alter the model equation and make wrong predictions about rest of the data points. Just like in our example, Bill Gates is indeed rich and his wealth is not wrongly recorded to be in billions, but including him in the analysis would give wrong results about others, and hence we are better off without including him in our analysis. So now that we have understood how outliers can cause serious problems in our analysis, let's understand different ways to get rid of them. There are 4 ways of treating the outliers: deletion, capping or imputing, data transformation, and binning. In the deletion method, we remove the entire row containing outliers. This reduces the data size and is not advisable, as we might lose some valuable information in the process, especially if the data size is small. Now, in case of large datasets consisting of thousands or millions of rows, deletion is possible and would not cause any significant difference to the final model we build. In the capping or imputing method, we do not remove any values, but impute or replace the outlier values using the average value or the median value or the mode value or the limit values. while we don't really know the right values to replace outliers with, but we try to replace them with values that make the least impact to the variable. In the data transformation method, we transform the variables such as taking the log value of that variable or the square or cube root for that variable, since log or square or cube root of an outlier is likely to be in the range of log or square or cube roots of rest of the data points. In the binning method, we form different bins based on the values of the variable and get the outliers treated. So we have overviewed all 4 methods of treating outliers. Now we'll write a code to treat the outliers by imputing method. Let us understand this with an example. We will be replacing the outliers with the limit value. We already defined the upper limit and the lower limit before using the quartiles and the IQR as shown above. Next, we need to define a function to replace the outliers with the limit values, that is, any value which falls beyond the lower limit is replaced by lower underscore limit value, and the values beyond upper limit are going to be replaced by upper underscore limit value. So we define the function as shown on the screen. Press Ctrl and Enter and the function is created, called as limit underscore imputer. Now we are just one step away from treating the outliers by imputing or replacing the outliers with limit values. We need to just supply the sale price in the input value parameter for limit underscore imputer function that we have defined. For that, we write the code raw housing data sale price equal to raw housing data sale price dot apply limit underscore imputer. Press Ctrl and Enter and you have treated your outliers. Let's again look at the descriptive statistics to validate if we have actually treated the outlier in the sale price. Type the code raw housing data sale price dot describe. As we can see that the maximum value has changed to the upper limit value, meaning that there are no more values beyond that in our dataset now for this variable. Hence we can say that we have treated the outliers for this variable. You would also notice that mean is now reduced, which is expected once you treat outliers. The mean value is still a bit higher than the median value, which means the data is not normally distributed and is a bit skewed towards lower values. Note that we are renaming this modified data as raw underscore housing underscore prices 1.csv. So we just answered the 5th question that we should answer while exploring the target variable. So that's it in this tutorial. In the next tutorial, we will discuss and answer the next question on how missing values can be treated.